Thank you. So, and I already have a nice conversation with the chairman, and he told me we should be very serious because a serious Polish conference, and already 3 people are watching. So I tell my neighbors, come here. No, there are 5 people at least here in the clouds. In the clouds, right? So thank you for the invitation. Thank you for the nice chairman, and he will interrupt me. This is his job. He will watch the chat and interrupt me so I can answer all questions live. So that's the deal. Okay, so we have just 40 minutes, so I will write some code because there's no more time for slides. So serverless Java in the clouds, this is the idea. And I have just fun with Java. I started with Java in 1995 and still like it. And I actually do more and more projects, so really busy. And I'm really looking forward to the next vacations, I would say. So yeah, because Java is really one of the most popular languages, right? So I have a podcast, which is fun. There are no ads, nothing, no business ideas, just chat with nice people. And if you have any questions left, maybe there's a couple of workshops coming in May about this particular topic, but this is maybe more interesting for you. The first Monday of the month, I'm answering all technical questions. So if there is no time left, because you only have 40 minutes, you can write a gist and I will answer it live. Okay, now about the topic. De-evolution. I spend a lot of time here with application code and on microprofile. What microprofile is like a fresh spec from Jakarta E. Chairman, are you there? Because you look frozen to me. I think this is just a screenshot of the chairman right now. Okay. So we have the microprofile spec, and we implemented microprofile applications. You maybe heard about Whitefly Swarm, now Quarkus, Helidon, and code like that. So, and these applications ran on Docker. So this was the idea back then, that you could package the application and run it on Docker. So now today I could say, okay, what if we could do this? So we will keep the same code and run it on serverless Lambda without any modifications or just minor modifications. And this is the idea I would like to share with you and have some live coding and explain you what the idea behind. Okay, now clouds. In my projects, so what usually happens, clients ask me, we have to go to the clouds. And then they say, okay, what to do? And they assume they have to run Kubernetes or virtual machines in the clouds. And the main idea is lift and shift. The problem with the lift and shift is the following. So we have here the orange part, which this is the shared responsibility model, which usually Amazon is responsible for. And we have the blue model, the blue part here. And the blue part is what you are responsible for. And the problem is, of course, there's too much responsibility on the customer, or customer means in this case on the developer. So what I would like to see is this. So this line should shift up. So I would like to focus on application logic again and not on the plumbing. So this is the basic idea of serverless. So the cloud care more about the infrastructure and the plumbing, and we developers write code what we did 20 years ago with Java, because I just skipped my history, but I spent a lot of time with Java E, Jakarta E, and why I like all these servers is because I just focus on implementing the business logic. I deployed to the application servers. I didn't care about the application servers at all. So it was like serverless servers back then. Okay, now what serverless is also good for. This is very good for management. So, for managers and management, level people. Why? Because I think in the first time in the history of Java, or at least as long of the internet, let's say, we get very precise billing. So this is what management likes. So for every transaction in the cloud, you will pay something. And you will see this on the bill. So it's hopefully not too much, but you will see, how expensive is this service and how expensive is this service. Whereby if you would run the same on Docker or Kubernetes, you only pay for hardware all the time, and you have no idea actually whether you are over-provisioning or provisioning the hardware. Are you paying actually more than desired? Which services are running inside the runtime is the next question, right? So with the serverless, what I like about is I get the bill, If something is expensive, we try to make it less expensive. If something is from the cost, okay, we don't optimize anything, regardless how much memory or CPU it consumes is just good enough. And so we bill or invoice profiling. So, and then what's also interesting here, scale to 0. So my chairman is active. Chairman, I was here at scale to 0. What I wanted to express is that what I like about this, that if you don't need your resource, you can just shut it down. Why it is so important? If you shut it down, you are not supposed to pay anything. So it's just free. Why it is important? Because in projects, what you can easily do, you can have multiple cloud accounts with your developer setup, and you are not paying anything. So because even if you would use Dynamodb database or S3 or Lambda, it usually you are not invoking it as a developer a million of times. So if you will pay something, it's just a small amount of money. Whereby if you're not using serverless technologies, then you will probably have to provision a larger Kubernetes cluster and partition it among developers. So it is a little bit more, I would say, complex, right? Okay, so now Java and serverless. So what's so special about Java? Actually, nothing special. This is in Java what we did, for years. The special thing is what we did for years, we can keep doing in the clouds. This is the special thing. So for years, we created larger microservices in Java. And now what we can do, we can run the same microservice as a Lambda function, for instance, with minor modifications, and it should run. And I actually plan to show you this. It executes fast, and actually it's going to be faster and faster because Java has optimization built in. So the AWS Lambda is executed once. It is the cold start, and from then, if you execute it periodically, it is going to be optimized by the JVM and is get faster and faster execution times. So we also have Maven. And why I mention Maven here, because I will show you in a second what I will use. I will try to deploy, an AWS Lambda with microprofile, and I will use a tool called CDK, stands for Cloud Development Kit, and this is Maven compatible. And what you can do is you can create reusable cloud modules and package the modules and push them to Nexus, for instance, right? This is what you can do. And so this is like a reuse of the plumbing. And you can use Quarkus and Micronaut. This is the both, a Micronaut comes with more like Spring-like APIs, and Quarkus is more like Java, Jakarta and microprofile compatible, but both are very similar, are very fast Java runtimes. And yeah, this is the last slide, and let's keep coding. And if you like, we see you in May. Or end of year, I plan another workshop, but yeah, I also have to spend some time in projects, so my workshops are not that frequent. So, okay, now, I plan to deploy a Lambda to my AWS account here, a Java Lambda, full stack Java Lambda, and the conference name is WDI. Okay, so I will like to use this name. And what I'm going to do, I will use the Quarkus, AWS Quarkus Lambda CDK plain template. So you can absolutely use it in your projects or for your Hello World examples. So you just clone it and run it. So what I will do in a second, I will just clone this this template and deploy it and explain what happens behind the scenes. Okay, now let's do this. Set up Quarkus. So this is a small script. What this script does is it clones the Lambda from the GitHub, or the Lambda, the template from the GitHub. And I plan to create a serverless application with the name WDI, which stands for something important. Warsaw Days of Informatics. So this is what it stands for. Serious Days for Informatics. So we should do this one because I said it's a serious conference. We should not joke too much. So this is serious. Warsaw Days of Informatics. So now let's do this. Now, this is Visual Studio Code, just very simple editor. And maybe I will do this. I will open that and open that. So you have two screens. Why two? This is application code, and this is CDK Cloud Development Kit. And what you see here, this is the Maven POM with a AWS dependency to the CDK. And what I'm also using is the API gateway. And this basically it. So this is just stock Maven. And I would like to show you there's a little bit infrastructure as code involved here. And I would like to deploy a Lambda, which is called Sirius WDI. And hello Warsaw in the clouds. Now, okay, this is basically it. So we are running 1 GB of RAM. I'm dedicated 1 GB of RAM for the Lambda. Why this? Because you get a half of CPU. If I would ship the Lambda with 256 of or 128 megs of RAM, it would be roughly 1/10 of a CPU. So 2 gigs of RAM is 1 CPU. This is how it works, how the cloud economics are working. And by the way, I'm for specific reasons, you can configure the Lambda to use the REST API gateway or HTTP API gateway. Today we only need the API gateway, HTTP API gateway, but yeah, let's delete it. We have some time, so make it simpler. So I would like to delete this, and the REST API gateway is not needed. So as you can see, the entire code in Java is like roughly 60 lines of code, and I could actually simplify it even further. So let's delete everything, and then it won't work. So let's do this. And then we also don't need this. We have no cross-account deployments, just simple Java. So we are here, no stack props, and I would like to remove this. And this basically is, so we have serious Warsaw days of informatics, I hope. And then this is some tags. And yeah, this is basically it. This is the entire project. So, okay, this is the infrastructure as code part. I think there's a unit test. And because, yeah, or let's fix this. Okay, now about the code. Now the surprising part here is the code is JAX-RS code, microprofile. It looks like old Java EE applications and no difference. With dependency injection, so I have here the greeter, and the greeter gets injected. I have some microprofile config with some default message. So let's say here, nothing configured. And I have 2 log statements, if greetings, and so this is the get statement and post statement, I think. So this is the get and post, exactly. This is the get and post. And that's basically it. So, and if you take a look at the POM, so there's nothing special. Rest easy. This is the arc is the dependency injection. JUnit 5. The only thing is I'm telling Quarkus I would like to deploy to HTTP gateway, and this is just for later use, because if you would like to connect to Dynamodb S3, usually likely you will need the URL connection client, but it's not needed for now. I think we are good to go. And so there is a small script called build and deploy, don't ask. And there is no magic there. So what this script does, it executes Maven twice. So it builds the Lambda first, and then it builds the CDK. This is what happens behind the scenes. So, and this takes a while. So I will just run it, build and deploy, don't ask. And so now, my Maven shouldn't ask me, but it would be perfect time to ask questions for me right now. And if there are no questions from the chat, the chairman maybe can tell me whether in Warsaw there are clouds right now or sunny weather, cloudless.
No, definitely it's not a sunny weather.
Oh.
There's a snow.
Snow?
You know, yeah. So
that's the problem. We cannot have a conference, online conferences when snows. There is this very bad, for the connection.
Talking about the clouds is merely possible, right? So it's a very, very challenging task. Okay, so Adam, please continue.
Very good. So we have almost fog, which is perfect for my talk, because I just Java now, builds and is deployed to the cloud. So their process here takes usually, I would say, between 1 minute and 80 seconds. It is depending on, I don't know, air pressure and temperature and whatever, and internet connections a little bit. So, but as you can see, I have a perfect connection directly to the cloud, but also perfect connection to my chairman, but not to the attendees. So this is we are like or maybe censorship is going on. The developers from other languages damage the network connection so that no one sees how great Java actually is. This could be the issue. Okay, so what I have here is, this is the URI of my Lambda. So I would like to pick the URI and do the time. And this is the cold start. So now the gateway starts in, 4 seconds now. So this was the very first call on Lambda with full stack microprofile application with CDI running on a half of a CPU. So now, if I do it again, it is significantly faster. So now we are down to 150 milliseconds. Okay, now come back to the browser. Where is my browser, actually? So disappearing browser could be also, here is it, a major problem. So, but this is the Sirius W, wait a sec, this was last modified. So this is the Sirius WDI. So as you can see, this is the Java Lambda, which is configured to be used by the HTTP API gateway. And we can switch to the to monitor, and I expect to see some metrics, but it is too early. So I open CloudWatch, and here I should see the log stream. So what the log stream is basically the log output from Quarkus, from the microprofile application, and this is already in JSON. So we are using structure logging JSON, and what interests me are the costs. So if I'm searching here for Bill, you will see how fast Java actually is. So what we see here is the very first call took 3 seconds. So the entire round trip from here to Frankfurt and back was the cold start around 4 seconds. So what it means, there was maybe half a second also lost at the HTTP API gateway, but I got only billed for half a second. And this half a second is the cold start bill. And then it got faster and faster and faster. So if I keep executing, it is going to be, I would say you can be around 5 milliseconds, right? So why it's getting faster? Because the Corretto Java virtual machine, this is what you get on the on AWS. It optimizes the bytecode. And as you can see, we are running with 1 gigabyte of RAM, which is over provisioned because we are consuming 160 megs of RAM. Which is, so I would say we could go with 256 megs of RAM, but the problem would be it will execute slower with less CPU, and it will make it even more expensive. So the sweet spot in Java is 1 to 2 gigs of RAM, where you can get the best performance and the most cost effective. I would say it won't be any more expensive than running with 256 megs of RAM. So in most of my production projects, we are running in 2 gigs of RAM. This is 1 virtual CPU. You can be as high as 10 gigs of RAM, then you will get 4 CPUs right now. But this is way too much for simple Lambdas. Okay, this was the now let's see how much this would cost, because it's all about cost in the cloud. So let's say this Lambda would be continuously executed the entire month. So my microprofile full stack application will be executed the entire month. And at the end of the month, how high would be the cloud bill? So let's do this. What I prepared is, there is the pricing calculator here. I already opened this, so I usually searching for this is, if you search for or calculator.aws, you will find that. And I would like to go, is it actually Poland region? So I don't even know. Maybe there's Warsaw. No, but Frankfurt. The next conference, there will be a Warsaw region. So architecture, we are running on ARM. I can show you where you can set it up. Wait a sec. This is visible in here. So we have, we are running on ARM architecture, and we are using Java 11, which means Corretto in the case of AWS. And Corretto was, even James Gosling was involved with the initial Corretto setup. And Corretto 11 is now available, and we are using ARM here. Okay. Yeah. this is the Frankfurt. So this is without free tier. So I excluded the 1 million calls per month to make it more expensive. So worst case, number of requests, let's say 5 per second. 5 per second. And the duration was 5 milliseconds or 8, let's say 20 milliseconds. And amount of memory allocated, we had 1 gig. So if you take a look at the calculation, so we are going to pay $6 for this function. And by the way, this is no more a function. It is a microservice. It can be as big as you can have. So currently in one of my projects, we have a AWS Lambda, which has 300 Java classes, and we have maybe 30 endpoints, and it behaves exactly like this. There's not a big difference. So now do you think that, the amount of Java code, of your code, of application code, makes a difference? What makes the difference, if you include lots of crazy frameworks, with reflection and whatever they are doing, then you will notice, a slowdown, but not with your application code. There's also a common misconception that I only have to find my code. Where is it? Here. That you cannot have, multiple endpoints, but you absolutely can. So what I could do, just try to let's say it Warsaw Warsaw resource.java, and this is application scoped, and path WDI and message fun is important, and get. And I think, I'm not sure about that, produces, maybe I have to tell, that we have text plain, media text plain, media type exactly, and text plain. Sorry for the connection, or for the bad connection, not for the connection. So let's see. So what I would like to do is, I would like to deploy it again. I think build and deploy don't ask, so it should redeploy the entire thing. And then I should be able to call the function with curl -i and /WDI. So the point is, you can have as many resources as you like. It's not like you think you are limited to one resource. You can have multiple resources and multiple HTTP methods. And so why this is so fast? So what's the trick actually behind the scenes? The trick is, what Quarkus does, it registers itself with a generic Lambda. And Quarkus is known for efficiency. So what Quarkus does at build time, it optimizes the bytecode. So there is no reflection in place, no strange class loaders in place. So the startup is very fast, and this is why it is so quick. But the interesting part is what we got. We got a stock microprofile microservice which runs as an AWS Lambda, which is an interesting point, because this is how you can migrate, some Java EE applications to the cloud. Let's see. So where is my? So now it's already done. So we can just repeat that. And instead of hello, I would like to have the WDI. This is the same URI. And as you can see, fun is important. Hello Warsaw, sorry for the bad connection. So this was the response from the cloud from Frankfurt. And it is still working. So this was the entire round trip, how it feels like. So now, the most asked question is how we can test such an application locally. And the interesting part is, what I have here stock Payara, I wanted to tell, stock Quarkus. So what I can do is I can switch to Lambda. And here I can say Maven compile Quarkus dev and just launch Quarkus in dev mode. And now what happens is I have my Lambda running locally here. And let's see. And I could just call Quarkus from my, wait a second, I just wanted that you see this. And I can just say, okay, I would like to invoke 8080/WDI, and I get here the response from Quarkus, and the other one's hello. And this is nothing configured because nothing configured was the response because it was the default. In the cloud, it was overridden by Lambda configuration. As you can see, this is nothing configured. But if I invoke the... Wait a sec. With my curl again, this is this one. Hello. I get different output, hello Warsaw, in the cloud. And the reason being is what I did is, in the CDK, I said, configure please Lambda with message, hello Warsaw in the clouds. And this is passed to the Lambda function. And now what Quarkus does, it just uses stock microprofile config, this is this, and ejects the property from outside, which can be used inside my application logic. So the great news are, you can write a little code, just focus on the business logic, and what Quarkus does, it makes it available as AWS Lambda, and in AWS Lambda you get, just a nice environment, serverless environment, where you just focus on business logic, and you don't have, to care about. If you like, you can run it behind a load balancer, but you don't have to care about VPCs and subnets for public deployments. So Adrian, is there any question? And I have no idea how much time do we have left.
Okay, so we have 5 minutes left. Let's start with the last part. And the first part, no, there are no questions, just the comments, and people are saying that it's great that you're performing the live coding, and it's a very interesting topic. However, well, I have experienced the same. So I have switched on the conference platform, and unfortunately there were some time frames where we were not able to hear you.
Okay.
There were audio problems.
Mm-hmm.
Okay, we have a question.
Mm-hmm.
So is Dynamodb an only database option for Lambda?
No. What you can use S3 Dynamodb. This is, I would say, the easiest option, because with Dynamodb, to get a table, I would just say, I would like to have table. As you can see, this is Dynamodb. I can say create table, and create the table right here, and it will create a table for me, and I would be basically done. So if I say table builder, create this, and say this is my table, then I can say table name is WDI, and the and what you need is the attributes, partition key, and this is going to be attribute and so forth. And this would create table for me. And but what you can absolutely use is Postgres. So to have a serverless Postgres, I would suggest you to use Aurora serverless. This is Postgres with wait a sec, where is my browser again? So we have here, if you search for Aurora, you have a serverless Postgres database. With Lambda, you have one problem, connection pools. So if you have a Lambda, and every Lambda will create, 5 connections to the database, we have, let's say, 5 concurrent calls, we get on top, 25 connections. So there are multiple options. What I would suggest is to use one connection per Lambda, or use RDS proxy. That's the name. And the RDS proxy is like the proxy between the Lambda and RDS, and it listens to your calls and pulls the connections for you. So Quarkus is well integrated with these technologies. What you can even have so-called IAM authentication for RDS. So you are not using username or password. You would use secure credentials. This is also working. The problem, of course, is if you have RDS, you have to pick your database, is Postgres or MySQL. Both options are available. And for commercial databases, Oracle or Microsoft SQL Server. And what Aurora is like Postgres with on Amazon storage. So it is clustering is easier, and you get master application. And there is serverless option as well. What it means is, if you're not using the database, I think default is 5 minutes. It will automatically shut down some nodes or some capacity, not nodes, to save the costs. Okay, so you can use whatever you like. The only problem you have to keep in mind how Lambda operates. It gets started and stopped. This is the main difference to application servers, where they are the entire time alive, and the connection pools was inside JVM, and the connections were used. But because a Lambda is a process, and we have many processes in parallel, it is harder to achieve with Lambda.
Right, thank you. And we have another question.
Very good.
I believe the last one, okay? Is cold start still a thing?
No, yes, on blogs and conferences it is. In practice, not at all. So and by the way, if you really don't like cold starts, what I could do, perfect. I could go here to provision concurrency and say I would like to have, and I think this is enter amount of 1 Lambda per hours per month. Hours per month. Wait a second. Terminal. This is no. Now we have 24 hours. I think 720, right? Yeah. So we need 720 hours here. 720 hours. Number of requests for provision concurrency, I think what we had 5 per second, right? 5 per second. And duration of requests, what we had 20 milliseconds, I think. And amount of memory was 1 gigabyte. So what this is, I would say I would like to have 1 Lambda running all the time and no cold starts. So this is like, the base load. And this will cost me 15 euros. So what it means, for 15 euros a month, I could run this application all the time without any cold starts. But if someone manages now, within the 20 milliseconds, to have multiple calls, all the other Lambdas will still have cold starts, right? So, but you only have a cold start if you invoke, Lambda once an hour or once and a half an hour. It depends on the region and settings. But it's not like the cold start only happens once, and then Lambda tries to reuse the environment. Very good question. Thank you. So if you don't like...
Thank you very much.
Yeah.